Running automated tests is a very important part of continuous integration, preventing failing code from being shipped to your customers. However, complex applications commonly have a very thorough test suite that can take a long time to execute. The goal of test intelligence is to reduce the amount of time it takes for your developers to get feedback that they have failing tests by using intelligent test selection. And this capability is unique to Harness and greatly reduces the unit test duration, many times by over 90%. We do this by learning what code paths are touched by each unit test. And then, based on what code is changed in a pull request, we can know exactly which tests are correlated to that code change. In this execution of unit tests for a large application code base, there's a total of over 6,700 tests. However, only 1,000 of them were correlated with the code change that was in this pull request. And additionally, 2 new tests were added, so we actually run those, as well as any updated tests if there were any. The result of this is that instead of taking almost an hour and a half for the developer to get feedback that they have 2 failing tests, these tests ran in only a minute and a half. To understand further how test intelligence works, you select a test and then view the call graph. This shows the tests that were run, the purple blob, and then direct and indirect calls in the code path that contributed to test intelligence selecting that test for execution. To start using test intelligence, you'll need to first add a run tests step to your pipeline. And in the configuration, you select the programming language and the build tool that your application uses. For some build tools, there may be some minor changes that need to be made to the app configuration. Just follow the steps in the wizard. The remaining settings here are the same as those in the normal run step, such as the command arguments to run your test suite and the path where the test reports are written to. Most importantly, check the box for run only selected tests to enable test intelligence. Once configured, to generate the first call graph, we need to run a full execution of all tests. This sets the baseline for test selection in future builds. Harness generates and updates this call graph based on webhook triggers for new pull requests and the push events for when that pull request is merged. So you'll need to open a pull request, and that will cause all tests to run. And then once complete, merge that PR to your main branch. Once you've done this, Harness has built a baseline and call graph for tests, and you can start using and enjoying faster builds on your next PR. But wait, there's more. You can use parallelism or test splitting with test intelligence to further optimize your test times. In the run test step YAML, there's 2 things to add. Define your parallelism strategy. In this case, we'll split the tests across 3 parallel executions. Next, to where the run-only selected test is true, also add enable test splitting to be true. Now, the next time you run your build, you'll know it's working when you see 3 test steps running in parallel. In the logs, you'll see splitting the tests as parallelism is enabled and successfully retrieved timing data for splitting. This is because, in addition to maintaining call graph of the tests, we also learn how long each test takes and take that into account when splitting the tests. So this ensures that the parallelism is as evenly split by duration as possible. And now the 81 unit tests in this suite were split into 3 separate executions that all ran at the same time, so 27 tests each. This has been an overview of test intelligence and test splitting in Harness builds.